The last part in this chapter is about clamper. And clamper means that you add a DC offset. You can add a positive offset or negative offset. That's why you have a positive clamper or negative clamper, or sometimes positive or negative clamper with DC power supply. So let's see how this works. So imagine that we have a signal like this one here. This is the input. Okay, so this is the input of the circuit. And we need to know what's the output. The output will look like this. This blue. It will look like this. So you see here, it is clamping. It is, you add a certain voltage here. If the maximum is 10, the maximum here is 10. The maximum here is almost 20. So something like this. So you add around 20 volt. I did this using B2 Spice. So it is not ideally supposed to be 10 volt. You add a 10 volt. Okay, so how you get this weird signal? How it look? Why it look like this? So let's return back and take step by step. Sorry, there it is. Take it step by step, half wave, half wave. First, is a condition for the clamper to work is that the time constant, which is R times C, is much larger than the frequency of the signal, or the period of the signal. T, this capital T, which is 1 over F, 1 over the frequency. For example, here for this circuit, the time constant is 10 times 10, so it is 100, and micro times kilo, which is the 10 to the power of negative 3. So 100 times 10 to the power of negative 3 is 0.1. So the time constant is 0.1. So you need 0.1 second to reach 60% of the maximum, to charge the capacitor with 63% of the maximum. This is the meaning of the time constant. Okay, but the period is much smaller than this 0.1 seconds. Okay, so the period of the signal is much smaller than 0.1 second. So this means that the frequency, which is 1 over t, is supposed to be much larger than 1 over 0.1, which is 10 hertz. And usually much larger than, when you have this much larger than sign, this means that's at least 10%, 10 times, at least 10 times. So if I said f is much larger than 10, then f is supposed to be at least 100, for example, 100 or more. That's why I choose this signal, Vn equal 10, amplitude 10, sine 2 pi f. F is 100, t, so f is 100 hertz. Okay, so let's see what happened for the output signal here if the input is sine wave. For the first half, look at the first half, the input signal is positive. So if the input signal is positive, then you have higher voltage here than this is the ground. So if you have positive here and negative here, or ground here, this means that the diode is reverse biased, which means that it's open. So you don't have this diode. That's why the circuit will look like this. If the circuit look like this means that the capacitor is charging. Is it charging, right? So if the capacitor is charging, this means that there was a voltage across the capacitor is increasing from 0 to the maximum. But because the time constant is large with respect to this is a half period here. Okay, the time constant is large. This means that the capacitor will not charge too much. Okay, so imagine that you have, for example, I'm giving you, for example, I want to give you a test. Okay, you have a test. This test is supposed to be solved in 1 hour. If I give you 1 second to solve it, or 1 minute to solve it, how many problems you will solve? Nothing, of course, nothing. So this is the idea here, that you are charging the capacitor, but you do not give it time to charge, very small time. So basically the capacitor will not charge. You will not have any voltage across the capacitor, or very, very small voltage. So in this case, the voltage here is supposed to be divided between these two elements. And because you don't have voltage across the capacitor, then all the voltage will be dropped on the resistor, which is this is the output voltage. So the output voltage is here. That's why the input and the output voltage are almost the same. There's no difference. Okay, so in this case, there is no clamping here. The output and the input are the same. There's no difference. Okay, now let us see what will happen in the next half. And the next half, I divided into quarters. When the voltage is negative, it's going down like this, and it is negative in both of them, but it is negative and going down in this quarter. What happened? In this case, this is what happened, that this one will be negative. This side is negative, and this side is ground. So this voltage here is higher than this voltage, then the capacitor will be short. So the diode will be short circuit. The diode is short circuit because it is forward bias. Then you will have this circuit here. Imagine that you have this circuit. Of course, here the time constant is what? C time what? The resistance is 0. You don't have any resistance because you shorted the resistor already. So the resistance is 0. Then the time constant is supposed to be theoretically 0. So this means that the capacitor will charge in no time or very, 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 very small time. So the capacitor voltage will reach the maximum. The maximum is what? Is the maximum is 10 volt in this. So of course this is positive here and negative here because it's negative. Then the current is moving in this direction and it will charge the capacitor. Then you will have a positive here and negative here. Then the voltage across the capacitor after this half here, this quarter, at this point, the voltage across the capacitor reaches the maximum, which is 10 volt. What will happen if the voltage start increasing again like this, the other direction? Okay. So this means that now that you will have the voltage across the capacitor is higher than the voltage across the source. This one is the maximum, which is 10 volt. This one is less than 10 volt for sure in magnitude. Then in this case, you will find that the voltage here, because this is the voltage of the capacitor, is higher than the voltage here, then the diode will be open. The diode will be open. Then you will have this circuit here, then which is very similar to the previous one. So actually you are doing what here? You are charging the capacitor here. You are charging the capacitor. So the output voltage here will be what? Will be the voltage at this point, will be the voltage across the capacitor and the source. Both of them, you add them. So V out equal what? Equal Vn plus Vc, which is the maximum, which is 10 volt. So it will be 10 volt plus the input. That's why you see this is the source. The source is here. You add 10 volt to it. 10 volt to it. Okay, this is 10 volt like this. Okay, but of course here you see that there is the voltage in this quarter here is negative 0.7 because, as I said, for the inductor for the diode, for the diode, when it is forward bias, the voltage is 0.7 volt. Okay, so if it is ideal, if the voltage is 0, then you will have a 0 voltage here. But because there is a voltage across the diode is 0.7 volt, it will be 0.7 volt when it's short circuit. So it will here, when in the fourth quarter, it will start from negative 0.7 until it reach what? Negative 0.7 plus 10 will be 9.7. Yes, negative 9.1. 9.3. Okay, so you add 9.3, yes, 9.3 volt. So the maximum here will be 9.3 volt. So this is what will happen in the fourth quarter. Why? Because the capacitor now is fully charged. Next part here, at this point here, from here now, when the voltage, the input voltage is positive, then the inductor, the diode is the voltage here is higher than the voltage here, then it is open. So you have this circuit here, and it will continue like this even when it is negative. So now if the voltage is positive or the voltage is negative, still the diode is open. Why? Because the voltage here in the diode here equals the voltage across the capacitor, which is fully charged. It has this 10 volt, okay, plus the voltage here. So it doesn't matter if it is positive or negative. You add a 10 volt to this signal here, which make it always positive for between 0 and 10 plus 10, which is 20 volt. So the voltage here will be always from 0, of course not always positive, from 0 to 20 volt. From 0 to 20 volt instead of negative 10 to positive 10, which makes the diode always open or reverse bias. Okay, that's why you have the voltage across the diode equals the voltage here, which is 10 volt, plus this voltage, whatever the voltage is. So you add a 10 volt to this one here. As you see here, it is not exactly 20 volt. The maximum is not exactly 20 volt because there was a voltage across the diode when it was short circuit, negative 0.7 volt. And this is the idea of the clamper. So when you continue like this, it will continue doing that. So only in this part here, the voltage, the first half, the voltage is the same. In the third quarter, it is negative 0.7. But after that, the voltage, the output voltage will be increasing or clamping like this by 10 volt. 10 volt is this number here. Okay, so this is the idea of the clamper. If we change the position of the diode is, for example, here positive, negative, we make it opposite direction. But the same idea, this we will create a negative clamper. So here we'll just make it like this. But when you look at the curve, this also curve is created by Beta Spice. Then you will see here that when the first half or first quarter here, it is positive. Okay, let's see. If this is positive, what happened? This one is positive. Then this one is positive, right? It's higher than this one. Then the diode here is short circuit. The diode is short circuit. Then the voltage across the diode is 0.7 volt. Okay. Then after that, then this one is short circuit. Of course, what will happen? So you will have this circuit here. The diode is short circuit. So during this quarter, the capacitor will charge to the maximum, which is VM, or I mean here 10 volt, which is 10 volt. The capacitor will be charged to 10 volt. This happened in the third quarter, in the previous one. Okay, but here it will happen in the first quarter. Then after that, because the voltage across the diode will be the voltage across the capacitor, which is fully charged by 10 volt, plus the voltage here, then you will add 10 volt to Vn. So you add 10 volt, then what do you add 10 volt or negative 10 volt? Let us see. When you charge the capacitor here, see, look at the current. Now the current will move in this direction. Then this one will be negative, this one is positive. Okay, this one is positive, this one is negative. Then when you charge the capacitor, this one will be negative, this one will be positive. Then the side of the diode will be negative here. This side is negative. Then actually you are adding negative 10 volt. Adding negative 10 volt to the voltage across the diode. So actually you are adding negative 10 volt to the input signal. This is the voltage across the diode. This is a negative clamper. This is a negative clamper. The next part, you add a DC power supply here. When you add a DC power supply, then in this case, of course, you add a voltage, of course, because this is just a DC power supply. If you add a 10 volts, 10 volts, 3 volts, 3 volts, and so on. So you add number to this already clamping here. This one is 10 volt, for example. If you add a negative 4, for example, then it will be negative 14, and so on. So this is the second one here. If this is a positive clamper, remember it's a positive clamper, then we added a 10 volt. If we add a 5 volt like this, then we add another 5 volt plus the 10 volt. Then, as you see here, you add a 5 volt to the input signal or to the output signal. So instead of having it like this, you add a 5 volt to this one here. So instead of the maximum at 10 here, the maximum is at 15. Supposed to be, of course. And then after that will be at 20, at 25, because supposed to be at 20. This is close to 20. This one will be close to 25. Okay, and so on. And sorry, this one is close to 20. This one is close to 25. Or this one is around 19 maybe. This one is 24. So when you add a voltage source like this is a clamper with biasing voltage. That's it. That's it. But usually, of course, you don't need to add a DC power supply, because if you have a DC power supply, then you can add the voltage if you want. If you have a voltage source, just a voltage source, then you don't need this. But you don't usually you don't need a power supply. So imagine that you have let's see here. If you have, for example, a voltage like this, here it is, source. Okay, then this is a sine wave like this, right? If you add a voltage source to it like this, here it is, the same, and you add, for example, 3 volt. So now what is the output between these two nodes? It will be this sine wave plus 3. That's it. So you add an offset here, but you add an offset using a DC power supply. But if you, the advantage of the first two, the positive and negative, that you don't need to add a power supply. You just have a capacitor. Okay, because the power supply costs money, of course. Okay, you need a battery, but here you don't need. In the first two, you don't need a battery. You just need a capacitor. The capacitor will charge and will do the job. Now let us see the problems. The last part are some problems here.